Hello, my name is Johnny Haboush and I'm a research scientist at the Virginia Transportation Research Council, the research division of Virginia Department of Transportation. And I'll be talking today about the performance test selected to evaluate the durability of asphalt mixtures, the Cantabro mass loss test. This test is performed in accordance with AASHTO TP 108 standard method of test for determining the abrasion loss of asphalt mixture specimens. In summary, a single specimen of compacted asphalt mixtures is placed within the drum of a Los Angeles abrasion machine without the charge of steel spheres. The specimen is subjected to a total of 300 revolutions within the Los Angeles abrasion drum. At the conclusion of the test, the percent material loss, referred to as Cantabro mass loss, is determined based on the original mass of the specimen. Significance and use. This test method is used to indirectly assess the cohesion, bonding, and effects of traffic abrasion on asphalt mixture. For the apparatus, we need a Los Angeles abrasion machine as specified in AASHTO T96. We need a chamber large enough to hold the Los Angeles machine with the ambient temperature controllable to a maximum margin of error of plus or minus 1 degree Celsius, plus or minus 2 degree Fahrenheit from the specified test temperature. Thermometers measuring ambient temperature placed in the proximity of the Los Angeles abrasion machine. Weighing device with a sufficient capacity be readable to plus or minus 0.1% of the sample mass or better and conform to the requirements of AASHTO M231. An oven capable of maintaining the appropriate temperature for drying specimen to a constant mass. Test specimens. The test specimen might be either laboratory compacted asphalt mixtures or sampled from asphalt pavement. The compacted specimen will have the following dimensions. For diameter, it's going to be 150 plus or minus 2 millimeter. For the height, it's going to be 115 plus or minus 5 millimeter. For specimen preparation, for laboratory prepared specimen, we need to condition loose mixtures for 2 hours at the design compaction temperature prior to compacting. For field-produced specimens, we need to minimize any cooling and bring specimen to the compaction temperature and compact immediately. For laboratory compacted specimen, we need a minimum of 3 specimens compacted under a gyratory effect as specified by the mix design procedure. For the test procedure, we will be presenting step by step on how to perform the Cantabro mass loss test. Step 1, we need to dry the specimen to a constant mass at a temperature of 52 plus or minus 3 degrees C, 125 plus or minus 5 degrees Fahrenheit. For step 2, we need to remove the specimen from the oven and cool the specimen to the test temperature of 25 plus or minus 1 degree C, 77 plus or minus 2 degrees Fahrenheit. The specimen shall remain at the test temperature for at least 4 hours. Step 3, we need to determine the mass of the specimen and record the value noted as W1. For step 4, we need to place the specimen inside the Los Angeles machine drum without the charge of steel spheres. Step 5, we need to turn the drum at 30 to 33 revolutions per minute for a total of 300 revolutions. Step 6. After 300 revolutions are complete, we need to remove the specimen from the drum. Step 7. We need to clean the specimen lightly with a cloth to remove particles that are loose on the outside of the specimen. Step 8. We need to determine the mass of the specimen after the test is completed and record the value as W2. For calculation of results, the percent mass loss is calculated at the ratio between the initial mass of the specimen and the final mass of the specimen over the initial mass of the specimen, all times 100. After calculating the percent mass loss for the 3 specimens, an average percent mass loss of all specimens tested is then calculated. Precision and bias. For the precision, work is underway to develop precision statements for this standard. For bias, the research required to establish the bias of the method has not been conducted. After the average percent mass loss is calculated, this value is compared to the Cantabro mass loss balanced mix design threshold of 7.5%. If the average percent mass loss is lower or equal to 7.5%, this passes the BMD threshold criterion, and that means that the asphalt mixtures meet the criterion for durability. If the average percent mass loss is greater than 7.5%, this means that the asphalt mixtures being evaluated fail to meet the BMD Cantabro mass loss threshold. As a numerical example, a specimen has an initial weight before performing the Cantabro mass loss test W1 of 5,229.6 grams. The same specimen shows a weight after the test of W2 equal to 4,699.4 gram after testing. The percent mass loss is equal to W1 minus W2 over W1, which is equal to 5,229.6 minus 4,699.4 all over 5,229.6 times 100. This will be equal to 10.1%. The same procedure is performed for specimen 2 and specimen 3. Specimen 2 shows a percent mass loss of 8.7%. Specimen 3 shows a percent mass loss of 10%. The average mass loss for these mixtures will be the average of the 3 values 10.1, 8.7, and 10%, which is equal to 9.6%. The average percent mass loss is greater than 7.5%, being the BMD threshold for the Cantabro mass loss test. That means that the evaluated mixture in this case failed to meet the BMD durability criterion. In this segment, I discussed the performance tests selected to assess the durability of asphalt mixtures, the Cantabro mass loss test. If you have any question, please feel free to email me. Thank you.